Hello, algebra students. We're going to continue our work with factoring today with some special types of polynomials. I'm going to share my screen and start the presentation. You should grab a piece of paper for today's warm-up. And this is section 7.7 today. So pause the video, try these problems, and come back. All right, our first problem said to factor the polynomial completely. If you'll notice, this is one where the leading coefficient is not 1. So it's what we were working with the last couple days. So I start with my parentheses. Factors of 25, my options are 1 and 25 or 5 and 5. I have this middle term of 10. So I'm guessing this is probably 5 and 5. I only have one option with a last term of 1. This has to be 1 times 1. In order to get a negative 10 middle term, let's see, I'd need negative 5x and negative 5x, so both signs are the same. A shortcut way to write that would be to write it as 5x minus 1 quantity squared, right? Both factors are the same. I can write that as an exponent of 2. All right, let's look at our next one. Again, our lead coefficient is not 1. We have a 6 this time. So our options for 6 are 1 and 6 or 3 and 2. Our options for factors of 2 are 1 and 2. I think, let's see if I can look at this. You guys have probably already checked it. I'm going to go with a 3x here and my 2x. And I'm going to do, let's see, yes, maybe 2. And this 1, and I need to get a positive 1. Now, my last term is negative, so one of these has to be negative and one has to be positive. If I look for my inside terms here, that's a 4x. My outside terms would give me a 3x. In order to get a positive 1 out of those, I would need 4 minus 3. 4 minus 3 is 1. So that means this outside here, I need to have negative, right? So negative 1 times 3x. And this is positive because positive 2 times 2x is 4x. All right, so it should be 3x plus 2 and 2x minus 1. Again, you could write that 2x minus 1 times 3x plus 2. You can't switch which number is which sign though. All right, the next one says first factor out the GCF before factoring the rest of the trinomial. All right, if you recall, when we were doing GCFs, we took something like 12x cubed and wrote it as, well, 12 is 4 times 3, so 2 times 2 times 3. And x cubed is x times x times x. All right, if I'm looking at 14x squared, that would be 2 times 7 times x times x. And 10x, the factors of 10x I would write as 2 times 5. All right, we're looking for what do these have in common. I'm going to switch colors here. I'm going to go with blue. All right, I'm seeing a 2 in all of them. And I'm seeing, an x in all of them. And it looks like I forgot to write down this one's x. So let me switch back here a minute so it's not confusing. This guy should have been 10x here. All right, now I'll go back to my blue. All right, so they all have a 2 and they all have an x in common. So my GCF here is 2 times x because that's what they all have. That's the GCF. And then to write the factorization, I put a parentheses after this. Remember, this is like the unfoiling part. So I have to think, what would I multiply 2x by to get 12x cubed? Well, let's look at the leftovers. 2 times 3 is 6. X times x is x squared, so I'd have 6x squared. My next term is positive, so I'm going to put a plus. I'm trying to figure out 2x times what will get me back to 14x squared. Again, you can see what's left over here is 7x. And my last term, 2x times what will get me to 10x? Well, my leftovers here are 5. All right, notice it says, first factor out the GCF before factoring the rest of the trinomial. All right, so I'm not done here. So I'm going to switch colors again. So now I have this expression 2x times 6x squared Uh-oh, my pen's being haywire again. 6x squared plus 7x minus 5. All right, to factor this completely, I leave my 2x on the outside, but now I need to factor this inside part, and it's kind of like we were doing in number 2 above. So factors of 6, my options are 2 and 3, or 5 or 6 and 1, and I'm going to try my 3 and 2 option here. And then I am trying to come up with a middle term of 7. So I'm going to put my 5 here and my 1 here, because then I have 10 for the inside, 3 for the outside, and I can get a 7 out of 10 and 3 by making this positive 10x minus 3x. Remember, you're combining the inside and the outside to get that middle. 10 minus 3 is 7. So now this entire thing, including the GCF, is my answer. All right, this is the factorization of that. And if you remember the other day, I talked about that this number tells you how many solutions. If I look here, I'd have 1 solution, 2 solutions, 3 solutions for this polynomial. All right, we're going to be factoring some special products. This core concepts is in your journal on page, if I can move this, it's hard for me to see that page number there, 236. All right, when factored, it says special products either look like a difference of squares. Remember these where you have just the same thing, the only thing different is the sign, or a perfect square trinomial, which is one of those that we can write shorthand as either a plus b squared or a minus b squared. All right, so let's look at some of those examples. All right, this is a perfect square trinomial. This is what it looks like in its form. This first term is something squared. The last term is something squared. And the middle term is formed by whatever those numbers were you used to square to get the first and last. The middle term is that product doubled. Okay, so this shows a perfect square trinomial. In factored form, it looks like this. Ax plus b, or combine it and put a squared. In this case, what do we square to get 25x squared? 5x. What do we square to get 9? 3. So 5x plus 3 quantity squared will give us this trinomial. And it's called a perfect square trinomial. All right, please add this example to the first note section on page 236. All right, whenever you come across these problems where there is no middle term, they're kind of fun because you know that they're going to look the same as far as numbers go. The only thing that's going to be different about the two factors is one is positive and one's negative. So first term, what do we square to get 9? 3. So 3x has to be at the front of both. Go to the last term. What do you square to get 25? What times itself is 25? 5 times 5. Again, the reason there's no middle term is because when you do your inside, you'd have a positive 15x. When you multiply your outside terms, you'd have a negative 15x. When I add 15x to negative 15x, I get 0. So there's no middle term. All right, please add this second example to the notes, the second note section on page 236. All right, the question is asked, is this a perfect square trinomial? So let's think. Can I square something and get 16x squared? Yes. 4x. Can I square something and get 1? Yes. What times itself is 1? 1. So now the question is this number here 2 times 4x times 1? Well, let's see. 2 times 4 is 8. 8 times 1 is 8. Is it a perfect square trinomial? Yes. All right. What would it look like in its factored form? Well, every time it's a perfect square trinomial, it's something squared. So I put what I squared to get 16, which was 4x. I put what I squared to get 1, which was 1. Since this middle term is negative, there is a negative middle term. All right, you can write that longhand as 4x minus 1 times 4x minus 1, but this is what a perfect square trinomial looks like. All right, let's try some of these. Grab my pen. All right, here's one of those where there's no middle term, which means the two factors differ by just their sign. So I'm going to have t and plus and minus. Go to this last term. What times itself is 81, 9, and 9. All right, 9t minus 9t is 0. 9 times negative 9 is negative 81. All right, this time, same thing, no middle term. I put my parentheses. What do I square to get 4? 2g, 2g, right? 2g times 2g. What do I square to get 25? 5 times 5. And again, I need one positive and one negative. All right, these look like they might be perfect square trinomials. So let's see, what do I square to get x squared? X. What do I square to get 64? 8. And is 16 2 times x times 8? And if the answer is yes, then my factorization is going to look like something squared. And what is that something? An x and an 8, and this is positive, so there's a plus. All right, let's try this one. This end would be a. What do I square to get 81? 9 times 9 is the middle term twice the product of a and 9. Let's see, 2 times a times 9 would be 18a. So yes, this is a perfect square trinomial. Make your parentheses, put your squared, put your first term that you squared, a, your last number that you squared, 9, middle term negative, put in a minus. All right, more trinomial factoring hints. Remember to see if the terms of the trinomial have anything in common. If so, you have to first factor out that greatest common factor, right? What they have in common, take that out first, and then factor the rest. The GCF will remain at the front of your factor trinomial. We had one like that in the warm-up. Part number 2 says, is the polynomial a special case, a difference of squares, or a perfect square trinomial? This can save you some time. Check your solution by foiling. All right, so even though you might have a special case, you can still use your same factoring methods to factor it. Oh, that's what this says. You can still factor perfect square trinomials and difference of squares with traditional factoring. Recognizing the patterns just make it easier. Your assignment today is 7-7 on page 401 in your textbook. There's a link to the book in Schoology. Again, if you have questions, you can just contact me by email. Good luck and happy factoring.